Hello, students. My name is Mr. Collins. I'm going to take you through the topic, the evaporation. Let's start with the definition of the evaporation. We say this is the transfer of water from the surface of the earth to the atmosphere. By evaporation, water in the liquid state is transferred into gaseous or the vapor state. The transfer occurs when some of the molecules in the water mass have attained sufficient kinetic energy to eject themselves from the surface from the water surface. The main factors affecting the evaporation are the temperatures, humidity, wind speed, and the solar radiation. The direct measurement of evaporation through the desired repo is difficult and possible only at point location. The principal sources of water vapor is oceans, but evaporation only occurs in soil, snows, and ice. Evaporation from the snow and ice the direct conversion from the solid to vapor is known as sublimation. Transpiration is the evaporation of water vapor, minute pores, or stomata into the leaves of plants. For practical purposes, transpiration and the evaporation from all water soils, snow, ice, vegetation, and other surfaces are lumped together and called evapotranspiration or total evaporation. I would like you to follow water as it cycles through the air, land, lakes, and rivers and oceans. The overview of the water moving through the hydrologic cycle or water cycle. It evaporates from the heart's surface as water vapor which condenses in the atmosphere forming clouds and precipitations, which falls to the land floor through lakes, rivers, ocean, from which water evaporates as a cycle and repeats itself. Let's look at the condensation. I say condensation. This is formed by the condensation of water vapor on condensation nuclei that are always present in the natural air and develops along the coast of King Range National Conservation Area in Humboldt County, California. The transition process from the water vapor to the liquid state is called condensation. Condensation may take place as soon as the air contains more water vapor than it can. The other one is the precipitation, and you say this condition occurs as the consequence of either cooling or mixing of air masses of different temperatures. By condensation, the water vapor in the atmosphere is released in form of precipitation. Example, if you have the Indonesia climate, that's most of the Indonesia receive heavy rainfall throughout the year. We move to we say again the precipitation that falls from the earth is distributed in four main ways. Some is retained to the atmosphere by evaporation. Other some may be intercepted by the evaporation, then evaporated from the surface of the leaves. Some percolates into the soil by infiltration, and the remainder flows directly as surface runoff into the sea. Some of the infiltrated precipitation may later percolate into the streams of the groundwater runoff. Direct measurement of the runoff is made by stream gauges and plotted against time on hydrographs. Most of groundwater is derived from precipitation that has percolated through the soil. And say the groundwater's flow rates compared with those surface water are very slow and variable, ranging from few millimeters and few meters deep. Groundwater is studied by the tracer techniques and remote sensing. Let's go to the Perito Moreno glacier. There's one in Argentina. Do you say the Argentina's Perito Moreno glacier is one of the several parts of the Patagonia that are cold enough to be covered by ice. We say the ice plays a role in water cycle. There's the ice and snow on the Earth's surface occur in various forms such as the frost, sea ice, the glacier ice. When the soil moisture freezes, ice also occurs beneath the Earth's surface, forming permafrost and tundra climates. About 18,000 years ago, glaciers, ice caps gathered approximately one-third of the Earth's surface of the Earth's land surface. Today, about 12% of the land surface remains covered by ice masses. Lastly, let's talk about the hydrometeorology. That's a branch of the meteorology that deals with the problems involving the hydrological cycle, the water budget, and the rainfall statistics of storms. The boundaries of the hydrometeorology are not clear-cut, and the problems of the hydrometeorology overlaps with those of the climatologists, and the hydrologists, and the cloud physicists, and the weather forecasters. Considerable emphasis is placed on determining the orologically or empirically. The relationship between the meteorological variables and the maximum precipitation uh, ranging from. These analyses often serve as the basis of the design for flood control and water usage structures, primarily dams and reservoirs. Other concerns of hydrometeorologists include the determination of the rainfall, probabilities, the space and the time distribution of the rainfall and evaporation, the recurrence interval of the major storms, snowmelt and runoff, and probably wind tides and wave in reservoirs. The whole field of water qualifiers supply the growing importance in the hydrometeorology. Up to there, we have come to the end of our topic that is on evaporation. I wish you all the very best and let us meet in our next class.